Hello everyone. In this video, we will see the example of backpropagation. If you are not aware about the theoretical concept of backpropagation, then see the previous videos on backpropagation. So we have seen the intuition behind backpropagation algorithm. So basically we want to learn these weights W1, W2 and these biases. Right? We want to learn this. So on new example, we can predict the value such a way that is very close to the original one. So which are the steps involved in that? So first is you need to compute the predict. So initially there will be some weights over here which are randomly assigned and bias which is also randomly assigned, and then using those random weights and biases we will find out this y hat. That is the first step to compute prediction. The second is you need to find out derivatives, means your gradients. So you need to find out your dw1 and dw2. This is your db1 and db2, right? This derivative that is with respect to your loss, right? Now after you find out these derivatives or gradients, the next step is to update the weights, right? So here we need to find out the new weights and biases, right? This W1, this is a new W1. How will you calculate that new W1? This is your old W1 minus alpha times dW1, means your gradients. Alpha, that is your learning rate. For W1, W2, B1, B2, we will update like this. So these are the three steps that are involved for neural network training, right? This is two-layer network, so you can easily write like this. If you have a more layers, so you can write in a loop this steps, right? But in this example, we restrict ourselves with two-layer neural network. These are the gradient calculation, 6 derivatives, right? Out of this, what we require? We require dv2, dw2, db2, dw1 and db1, right? Let's see the example. So in this two-layer network, w11 equal to 0.4. We have assigned some weights 0.4, which is going from first neuron to the first neuron at layer 1, right? This is your input layer, this is layer 1 hidden layer, and this is your output layer, layer 2, right? So 1 1 means going to layer 1 from neuron 1, from neuron 1 and going to which layer? Layer 1. Take another one, W121. So means it's going to neuron 1 which is at layer 1 from neuron 2. You can say this is the second neuron. From second neuron it is going to first neuron, right? That's why W12, and this is layer 1, 0.3, right? So this way we can see these are the weights. Now, if I need to write these weights in or use as a vectorized version, right? I will use W1, which consists all these weights, right? And what will be the size of W1? The size of W1, that is equivalent to 3 cross 3, right? It stacks all the weight vertically. It stacks all the weights vertically. Means the first row, that is weights going to neuron 1. The second row is weights going to neuron 2. Third is weights going to neuron 3. Likewise. And here these are the W2. Okay. Now to find out, the first step is compute prediction, means y hat. So to find out this y hat, what is y hat? That is your A2. Right, this is A2 because there is only one neuron. So A12 you can write like A2. So these are the four steps that you need to follow to find out this y hat. Right, so first is Z1, W1 into X plus B1. W1 into X plus B1. Right, so what is the value of W1X and B1? So W1 is 0 0.4, 0 0.3 and 0 0.2. What this first row indicates? So first row that indicates weights going to first neuron which is at layer 1. Let's see. This is first neuron of layer 1. Which are the weights? This is the first, second and third. This is bias. So first weight is 0 0.4. So 0 0.4. Second is 0 0.3. So 0 0.3. And third is 0 0.2. This first row that indicates weights going to neuron 1 which is at layer 1. Same way second row that indicates weights going to neuron 2 which is at layer 1. Right, so this is second neuron. The weights is 0 0.1, 0 0.3 and 0 0.2. 0 0.1, 0 0.3 and 0 0.2. Likewise third neuron. Right. So number of rows that depends on neurons in this layer. Right, so here 3 neurons are there. So this will be number of rows will be 3. And number of columns, it depends how many neurons are in previous layer, means your input layer. So that is 3. That is 3, right? If we have 4 neurons, then this will be 4 cross 3. But right now we have 3 neurons in layer 1, so that is 3 cross 3. Now X. Here we are taking only one training example, right? And in that one training example, how many features are there? We have 3 features. The number of neurons that is in input layer, that indicates number of features. So here we have 3 neurons. So there are 3 features, x1, x2, x3. And the value is 0 0.3, 0 0.5 and 0 0.4. So 0 0.3, 0 0.5 and 0 0.4. Right? So this is your x. If you write capital X means on all training example, then you will stack each training example vertically, not vertically, horizontally, like this. So first, that is first training example, second column, second training example, likewise. But here, for this example, we are taking only one training example. Then your bias B1. What this indicates? it indicates the bias that is going to all neurons, means going to each neuron which is at layer 1, right? So first neuron, which is the bias 0.2, second neuron, what is the bias 0.15, and third neuron, the bias is 0.18, right? So here the bias is 0.18, right? So B21, bias to neuron 2, which is at layer 1. So if you solve this, then the result will be your Z1, right? And Z1, what is Z1? It is vertically stacking of Z11, Z21, and Z31, right? So the size of Z1, that will be 3 cross 1. Now let's see. So this is W1 into X. So you will get this because W1 is 3 cross 3 and your X is 3 cross 1. So result will be 3 cross 1 plus this is also 3 cross 1. So if you perform addition, what you will get? You will get this Z1, that is also 3 cross 1. So 0.55, what is that 0.55? That is Z1 1. What is 0.41? That is Z2 1. And 0.44, that is Z3 1. Right? So this is the vectorized version. That's why we get this Z1 directly. Right? Instead of calculating individual Z11, Z21, Z31 likewise. So we have performed this calculation Z1. Now next is A1. What is A1? A1 is activation on Z1. So here we use sigmoid activation function, right? So what is the sigmoid activation function? The sigmoid activation function, G is equal to 1 upon 1 plus e raised to minus x, g of x, right? So if you use that activation function and if you perform on Z1 means to individual value, then it will give you this value, means g of Z11, that will give you 0.63, g of Z21, that will give you 0.60, g of 0.44, that will give you 0.61, right? So this is your A1. So we have performed calculation of A1 as well. Now next is your Z2. Z2 is W2 into A1 plus B2. So this is your W2, right? And output from first layer. Output from first layer, right? So this value is 0.63. What is that? A11. This is A21 and this is A31. Okay. Now W2 A1 into A1 plus B2. So what is the value of W2? So value of W2 is like this: 0.3 into 0.3, 0.2 and 0.25. Why only one row or the size is 1 cross 3? Because what is W2? It's the stacking of weights going to all the neurons which are at layer 2. So at layer 2, how many neurons are there? Only one, right? So there will be only one row because there is only one neuron. Now to this neuron, how many weights are there? There are three weights, right? So 0.3, 0.2 and 0.25. So 0.3, 0.2 and 0.25. weights going to neuron 1. Suppose if I have second neuron here, then and weights are going to that neuron as well. So in that case, I will have another row with some weights, right? So you can see here 1. Why? Because in layer 2 only one neuron is there. This is 3. Why? Because in previous layer there are 3 neurons. That's why. Multiply by A1. What is the value of A1? This is your A1, right? So we are writing that A1. So ultimately your Z12, that is summation of multiplication between A11 into W12 and A21 into W122 and A31 into W132. And if you add this three value, that will give you plus your bias, that will give you Z12. So same thing that we can perform using this matrix multiplication. Because here if you multiply this, then what you will get 0.3 multiplied by 0.63. That is your first term, this value 0.3. What is A11? A11 is 0.63. That is 0.3 into 0.63 plus 0.2 into 0.60 plus 0.25 into 0.61, right? And plus your bias. There is only one neuron, so only one bias. So if you perform this, you will get the value of Z2, that is 0.56, your Z2. Now what is A2? A2, that is our prediction, right? Because output from this neuron, that is your prediction. So A2 is our output. What is A2? A2 is activation on Z2, and we are using sigmoid activation function. So if you perform sigmoid on 0.56, that will give you a 0.64, right? So now we have prediction. What is that? That is 0.64. And assume that your y original, that is 0.7. This is your original y, right? And what we have predicted? We have predicted 0.64, right? So we'll find out the loss. This is your function for find out the loss. If you use this, then you will get the loss that is equivalent to 0.265. And what is our target? Our target is to minimize this loss. We want to minimize this loss, right? So how to do that? So what we do using this loss, we will check what is the contribution of weights and bias in this loss and how to update those weights and bias to get minimum loss. So we'll update those weights and bias according to that. Okay. So now the next step is to find out the derivatives, because this is useful to update your weights and biases. So to update this W2, B2, W1, B1, what we require? If you recall the gradient update, then you require gradients, that is dw2, db2, dw1 and db1, that you require, right? So we will find out this value. How to find out those values? So we have seen the derivative and the equation for that. So these are the equation for that. So how you can find out dw2? So using that dz2 into a1, right? Using a1. So a1 we have calculated. You can see in the previous slide. So A1 we have calculated. DZ2 we need to find out. So how to find out DZ2? So to find out dz2, we require a2 and your y original. If you have this, then you can find out dz2, right? So to calculate dw2, we require dz2. And what is db2? db2 is your dz2, right? Now we require dw1. What is dw1? dz1 into your x we have, that is your training example. dz1 we need to calculate, and we can calculate using this equation. And this is derivative of activation, which is at layer 1, which is at layer 1. Next is db1, that is your dz1. So derivative, how we'll get this equation, that we have seen in the previous video. If you not getting this thing, then I request you to see that video. Now let's see the calculation. So first is dz2, that is equivalent to a2 minus y. What is a2? We have seen that a2 and y. So your a2, that is 0.64, right? And your y means original, that is 0.7. If you perform this operation, you will get minus 0.06, right? Then your db2, this thing, that is dz2 into a1 transpose, right? Why we are taking transpose? If you see a1, right? If you recall the size of a1, then the size of a1, that is 3 cross, size of a1, that is 3 cross 1, and your dz2, that is 1 cross 1. So you cannot perform multiplication or the correct multiplication. That's why you require transpose of this, and that will be your 1 cross 3. Right? Now the multiplication is possible, and the result will be 1 cross 3. So this is your result, dw2. Now what this individual term means? This individual term is, this is your dw112, means derivative of your loss function with respect to w112. The second term is derivative of loss function with respect to w122, and the third is dw132, right? So we are performing vectorized implementation, that's why we are getting directly this value 1 cross 3, right? So first is your dw112, second is dw122, third is dw132, right? Now the next is db2, right? So what is db2? db2 is your dz2, that is minus 0.06, right? So that is your db2, and we have only one neuron at that, so that's why what you will get here, 1 cross 1, that is minus 0.06. Now next, dz1. So in dz1, what is required? w2 dz2. We have dz2 minus 0.06 and your w2. If you recall your w2, that is 1 cross 3. w2 is 1 cross 3. If you take transpose, then that will be 3 cross 1. And your dz2, that will become 1 cross 1. Right? So you can see here, before transpose, w2, that is 1 cross 3. And your dz2, that is 1 cross 1. So you cannot perform multiplication. Right? So we are taking transpose, and after transpose, that this is your 3 cross 1. And dz2 is 1 cross 1. Now you can perform multiplication, and the resultant matrix that will be 3 cross 1. This is element wise operation, right? And this is the derivative of your activation, right? The sigmoid derivative of sigmoid activation function. What it indicates? It indicates, or if g of x, that is your activation, then derivative g dash x, that is equivalent to g of x 1 minus g of x, right? So this derivative g1 dash into z1, that will give you a1, because the a1 is activation on z1, right? So a1 into 1 minus a1, a1 into 1 minus a1, right? So if you solve this, you will get this value, and at the end, after performing this element wise operation, right, multiplication, element wise multiplication, you will get this value of dz1, right? So we have calculated dz1, and the size of dz1, that is 3 cross 1, right? So this is dz1 1, this is dz2 1, this is dz3 1, right? So derivative of loss function with respect to z1 1, derivative of loss function with respect to z2 1, derivative of loss function with respect to z3 1. So these are the values of dz1. Our purpose to calculate dz1 is to find out dw1. So how to find out dw1? So dw1 is dz1 into x transpose. Where we are taking transpose, that we'll see. Your dz1 is this 3 cross 1, right? And your x, small x, if you see that small x, then that is your 3 cross 1, right? 0.63, 0.60, and 0.61, your small x, right? If you take transpose of this, then you can perform multiplication of this function. And why we are taking transpose of this? Because when you perform this transpose, you will get this matrix, that is 3 cross 3. What this 3 cross 3 matrix tell you? So this first one, that is your W111, and this is derivative of loss function with dw11. Second is dw121. Third is dw131, right? So if you perform matrix multiplication, then you will get this matrix. So now with this matrix, we are calculating the derivative of that particular weights, individual weights with respect to loss. And what is the size of our W1? Size of W1, that is 3 cross 3. right? And if you find out dw1, then that must be 3 cross 3, means loss derivative with respect to that loss with this weight, that must be, that must give you this 3 cross 3 matrix only, right? Similar way, this third row, that will give you dw3 1 1, and this will give you dw3 3 1, right? So this is your dw1. The last one is dz1, db1. So db1 is equal to dz1, and we have calculated the dz1, so you can directly write that dz1, right? So your uh, first term here, that is your db1 1, and last term is db3 1. So now what we have? We have dw2, db2, dw1, and db1. So we have calculated the gradients, right? Now the next step is we need to update it, right? So next step is gradient descent update. So using this four equation, you can update your weights and biases. Here your alpha, that is your learning rate, and in this example we will keep it as 0.01. Let's see first W1. So your new W1, that is equivalent to your old W1 minus alpha into derivative, that is dW1. This is your W1 minus alpha 0.01 into dW1. We have calculated this thing. If you multiply this with all the elements and if you subtract that, you will get this value. So after performing this training, what you can observe here, the W111, this value, that is now updated with this value 0.40003, right? Very minor change. Why? Because you can see the difference in loss, right? The prediction was 0.63, and our output means original y, that is 7, means very close. That's why you are seeing here very small change. Same way another one, then b1, that is equal to b1 minus alpha into db1. So if we see this 0.20, 0.15, and 0.18, that is the old value, minus alpha into db1, you will get this new b1. So again same, this is your b1 1, new b1 1. This is the old one, b1 1. This is the old one, right? W2. So you can calculate like this, W2, right? W2 0.3, 0.2, 0.25 minus 0.01, and you will calculate get dW2 like this. Ultimately, you will get this value of W2. This is the old value, and now this is the new value of your W2, right? The next is B2. So here B2 minus alpha into dp2. So what you will get? You will get this value 0.1006. So this is one pass. We have training example using the initial weights and bias. We have calculated y, and then we have find out the difference and check the loss. Then we find out the derivatives or gradients, and then we have updated weights. So same way, these steps, if you carry out, right, for number of times, right, you will fine tune your weights and biases. Once the training overs, you will take these updated weights and biases, and using those weights and biases, you will you will apply those weights and biases on new example, and that will give you a very close prediction, right? So that's it for this video. Thank you.